Hello, welcome to Materials and me, Materials being the study of stuff, and me being Ire. I want to talk about materials characterization. And obviously, you can Google this and get some long, elaborate definition. But today, you guys are going to get the Ire Dictionary definition of materials characterization.
Okay.
And essentially, it's a character profile. And just like a human being, when you're getting to know a person, there's different techniques that are more appropriate than others to find out different things. So, for example, person X, let's call him. Okay, let's give the person a name, Bob. I hear about Bob. I want to know more about Bob. I find him on LinkedIn, and this Bob is a guy. Let's make that clear. So I find him on LinkedIn, and I see, his achievements, his accolades, whatever. That's what doesn't tell me his character. I'm after the character. Is he funny? Is he loud? Things like that. So I talk to somebody, a mutual connection. The person tells me, Bob's like this, Bob's like that, whatever. With each method, the first one, just looking at a profile, the second, talking to someone that knows the person, those two methods, I've acquired a different level of information about this person. Now I'm going to acquire even more information about Bob when I actually speak to Bob directly. And that's what I'm trying to say is the same thing with materials characterization techniques. Depending on the techniques you're using or the material you have, or even the information you're trying to acquire, you're going to need to do different things. And sometimes some techniques are just overkill depending on what you need to know. Like if I never really wanted to know about Bob's character, talking to him or even somebody that knows him is irrelevant. I just want to know what school he went to. The LinkedIn information is enough. And it's the same with materials characterization. So say you have some cling film and I want to confirm what type of polymer it's made of. I could use optical microscopy to look at it just to say I've looked at it and observed it's at a microscopic level, but really and truly, what I'm trying to know is the composition. I want to know what it's made of. So, straight away, what I would do is use Fourier transform infrared. Is it spectrometry or spectroscopy or FTIR? I always call it FTIR, so I always forget the last bit. But, anyways, this technique, the database has like a library of different polymers, and it's just the go-to you use for polymer analysis. And although I could use SCMEDX to find compositional data about material, but some techniques are just overkill. There's different techniques that are more appropriate than others to find out different things. I had some nickel samples and I wanted to measure the grain size, and I'd been struggling because I had heat treated the samples. Because of how large the grain size was, I was struggling to get the measurements through like my SEM micrographs. So the pictures I was taking using the SEM, it was just about one grain would fit in the image, or one and a half, sometimes two, but not that many. And so I basically just used an optical microscope, and then I used, what's that thing called? Image J. I took the pictures and then I used Image J and I measured the grain sizes that way. So sometimes it's an even simpler technique and you don't need to overcomplicate things. I'll give you another example of this thing I'm telling you about. Undergrad, I was looking at the solution of nuclear waste glass, basically corrosion of nuclear waste glass. And we were looking at two things: the glass itself, so the actual solid, and then we looked at the solution chemistry, so how much has leached out of the glass into the solution we put it in. And the analysis technique we used to look at this solution was ICP-OES. So in going into my masters and having to do like electrolysis experiments, obviously I have another solution I'm looking at, but except I'm using the solution to as my electrolytes. But that's by the by. All this context is to let you know that I used ICP-OES before and I thought I could use it again, until I realized when I was getting the training that actually it's not just a blanket, oh, all solutions can be analyzed using ICP-OES. They need to be, the particles need to be completely dissolved in your solution in order to do the analysis. because you're using a plasma, so they need to be very, 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 very tiny. And my solution wasn't even really a normal solution where everything is dissolved. It was a colloidal solution. So basically, the particles haven't committed. The particles have commitment issues, so they don't fully dissolve into the liquid, and they sort of like hanging. They're like, yeah, I think I like you, but I'm not really ready to like, be in an exclusive relationship. That's basically what this was. But anyways, what I'm trying to say is it wasn't gonna work for this thing, even though at a surface level, no pun intended, at a surface level you would think that it would work, but it wouldn't have been very effective. So I had to scrap that. And I think the alternative was actually going to be what's the name? Oh goodness, I don't remember what the alternative was, but in that scenario, I had to look for an alternative method to look at my solution chemistry. So sometimes, yeah, you have to pivot even when you think something would have worked, and then you find out, oops, I made a mistake. And I think just like when you're getting to know a person, like the example I use with Bob, sometimes you find out actually I don't need to know that much, or I can't use that method to find out that bit of information, and then you pivot. And so, yeah, I think doing Materials characterization was like one of the things that made me realize that no, I like this. So I think especially with uni, and just trying to study things theoretically, it can be a bit difficult to sort of like understand, okay, but in like real life, like if I'm looking at XYZ sample and I'm trying to get this particular material property or this information about this material, like how would I actually do it? Because obviously they can tell you, oh, this technique is for tensile testing, this technique is for this. But in reality, like knowing what to prioritize at certain points, obviously I haven't given you all the answers you need, but just I'm trying to like help you think about it more. Like this is the sort of mindset you need to have. And just like trying to put a bit of meat on the theoretical skeleton we get in school or in uni or from reading something. And so I hope this was a bit helpful in seeing how materials characterization actually plays out when you're in a lab or when you have a material in hand. So, as per usual, if you made it to this point in the video, good on you, good on me. Let's keep doing this. Stay curious. I ran out of storage again. Oh my goodness. But yeah, I'm really upset because I said some other good stuff. What's the thing I was trying to do? I was going to say something just now. I don't have the storage to be doing this.